Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today's discussion basically is going to be a concept on the concept of a force, and we have come across these specific terms in our various discussion, especially on the concept of Newtonian laws. And today's discussion is basically going to assist us identify the various forms of forces which we are going to come across in our various topics. So in this case, from Newtonian's laws of motion, we had said that we can describe the concept of Newton's first law of motion as the state of an object being at either at rest or in a state of motion. And we said that if this specific object is displaced from point A to B due to the influence of a force given in this specific case, then we can, of course, describe the various aspects of a velocity component for this particular force. So let's assume that this is going to be in the x direction. And specifically, as we said, the concept of Newton's first law is going to be a description of the force in one dimension given in that particular case. So in this case, we shall have this particular object in a state of rest given its velocity component as 0. And therefore, we shall have this aspect of acceleration as well given in terms of 0. Now, for the second case, we said that if an object is going to be in a state of motion, we can describe its velocity component in terms of v plus the initial velocity. And of course, we're going to describe this specific acceleration in terms of 0. So we had said that if this object is going to be caused to move, then it's going to move with a constant, of course, as velocity component given as that one. So if there's no change in velocity, then therefore we're going to have that one automatically implying that we're going to have a 0 acceleration. So this, of course, is going to be the implication of Newton's first law of motion, whereby we said that a body or an object will continue to be in its state of rest or motion with a constant velocity unless we are going to have an external force interfering with a specific object. Now this, in contrast with the second law of motion, of course, that is going to assist us predict behavior of objects with all existing forces which are going to be, of course, unbalanced. And now from the first case, we had said that basically for this first Newton law of motion, the forces experienced are going to be balanced, whereas for the second case, for Newton's second law of motion, the forces involved are going to be unbalanced in this specific case. And therefore, this is going to be resulting in giving a relationship between the nature of force applied and the mass, which are the two fundamental variables which we can rely on in trying to describe Newton's second law of motion. And of course, the third law of motion gave us the nature of the forces involved and their particular magnitude, whereby we said that for interaction of two objects, they are going to exert equal but oppositely directed forces on each other given in terms of this specific, of course, formula. So we're going to have this one given as that, and this is going to be forming a summary of our description of the three basic Newtonian laws of motion which you have looked at in our previous video. In this case, for the first case, I've mentioned the concept of a force, and the second case, and the third case, of course, is going to involve this aspect of a force. Then therefore, we can question ourselves what this aspect of a force basically is. And therefore, we are going to, in this specific discussion, identify this aspect of force which we have come across in one or another in some of our videos. And in a sense, of course, I've said that for a force to be experienced, we're going to have two interacting objects, as we have said for this first case, for the first law of motion, whereby an object is going to exert a force on another one. So we're going to have this one as object. So we're going to have interacting objects given as that one. And of course, as we said, these are going to assist us in trying to, of course, give this particular impression of the concept of a force. So we can define a force as a push. So a force, so let's have it, this one as a statement, a small statement in summary form. A force refers to a push or a pull, of course, which is going to be acting upon an object resulting from an object's interaction with another one. So of course, this is going to be the implication of this interaction of these two objects which I have said, which is either going to involve the concept of a push or a pull for that case. So we can define a force as a push or a pull upon an object resulting from the interaction of the object with another one. So whenever there's this whenever there's going to be these two specific interaction, there's going to be a concept of a force, and a force, of course, is going to be resulting as, of course, a result of this specific interaction. Now we can categorize these forces into two broader categories, whereby we're going to have this one given in terms of interactive forces, or the forces which are going to result in terms of some kind of a contact. So we can give them in terms of a contact forces. Now, from this specific wording of the concept of a contact forces, we're going to experience a nature of forces whereby objects are going to interact. Of course, perhaps the surfaces of this specific object are going to be interacting due to the cross proximity, or of course the nature of course, attraction, or the nature of interaction is going to involve contact. Whereby one of the example of forces which are going to fall under this category is the concept of friction, whereby the surfaces of two objects are going to be rubbing against one another, and of course that is going to result into the nature of force which we are going to refer to as a contact. And we're going to have the concept of cohesion. Whenever we're going to talk about surface chemistry and other subjects, or rather the concept of a capillary action, we're going to see this specific aspect of a force coming into play. And then in describing of liquids, the resistivity to flow, of course, is going to be described by the concept of a physicosity. A physicosity is going to be another type of course, force which is going to be experienced due to a resistance of a liquid to flow given in that specific case. So the interaction of air and other objects is going to be resulting in the concept of air resistance, or air resistance. So in this case, we can just have this one as air resistance, given as another type of a force which is going to be falling under the category of contact forces. And lastly, but not least, we can as well talk about our applied forces, which we are going to mention, particularly in some of our videos, especially on the concept of application areas. So in this case, these are some of the type of forces which we are going to come across for friction, cohesion, viscosity, air resistance, and some of the applied forces, which are going to be categorized as contact forces. So for our second case, we're going to have another category of forces resulting from action at a distance. And in this case, these are going to be contrasted with the first forces, whereby we're going to see that the surfaces are not going to interact, but there's going to be some nature of forces which are going to be experienced. And one of them we have already discussed about. This is a magnetic force, a gravitational force, which we have already looked at. And perhaps we're going to look at electrical fields, which of course is going to be an electric field force which is going to be experienced in this specific case. So generally for this one, as I had mentioned from our previous discussion, especially on the Newton's second law of motion, we said that we're going to have this SI unit for this particular aspect of forces given in terms of newtons. So the SI unit of force is given in terms of newtons. So whenever we're going to do our evaluation examples, they are going to be assisting us in trying to, of course, represent this specific aspect of the forces in terms of the SI units. So kindly check out description boxes for various links of other videos, and also engage us in the comment section, subscribe, and also ring that notification bell for various updates in the concepts in mathematics and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.